Math 2 students. Today we are going to go over complex numbers and operations with complex numbers. So far, anytime you've encountered a square root with a negative under it, you've just been told that you can't take the square root of it, or there's no real solution, no real answer. Today we're going to actually talk about what we do and what we can get from taking the square root of a negative number. All right. So kind of the way we combat this is we define the square root of -1 as I. So whenever you have a square root of a -1, you can simplify it to I when you evaluate the square root of -1. All right. So an imaginary number is a number that is expressed, I'll say expressed in terms of the square root of a negative number. So basically, you guys already know how to break down radicals. So basically what you do is you take a number and you can take the negative away from it by pulling the -1 out and then evaluating it. So like, for example, 9, right? We can break that down into 9 times -1, and we can take the square root of 9, which is 3, and the square root of -1, which we've just learned is I. So that would be our answer, 3I. All right, if we look here. Now, we know we can't take the square root of 5, but we can take the square root of -1. So we could break -5 down into -1 times 5. Square root of -1 is I. We get I root 5. And something like this. Again, we want to pull that -1 away from the 72. And we would use our perfect squares to figure out what's the highest perfect square that goes into 72. That is going to be 36 times 2. So then we can take the square root of both the 36 and the -1. We get 6I root 2. So that is how you end up with I values, is you evaluate the square root of a negative number. Now, an important piece of information that you're going to need to know is that I squared is equal to -1. Now, how does this happen? Well, we know that the square root of -1 is I. So when we square that, right, when you square something that's inside of a square root, the square root goes away and the inside pops out. So that's how we end up with a -1 when we square I. All right. So, and complex numbers are expressed as A plus BI, and I is an imaginary number. Oops. All right. So the nice thing about I is you basically just treat it like a variable until it has a power on it. Once there's a power on it, you have to kind of do things with it and simplify it. Essentially, you use this rule that if you have an I squared, it can be replaced with a -1. But beyond that, you just treat I's like variables. So here, we're adding. So it's just going to be like combining like terms, right? So 4 plus -11 is going to give us -7. Then we've got -7I and positive 9I. That's going to give us a positive 2I. And that would be our answer. You really do just treat the I's like variables. Now, one thing I want to point out is you really do want to keep it in like the A plus BI form, which means that you just want the imaginary part to come second. That's kind of just a standard way of writing it. All right, so here we are subtracting a complex number from another complex number. So remember, when you have a negative sign with two terms following it, you have to make sure that, I should say negative sign with two terms inside the parentheses following it, you have to make sure that you distribute the negative. just like we normally would. And again, we just combine like terms like we normally would. So far, nothing has really changed. You guys probably already know how to do this. If we had just replaced the I with an X, right? It's pretty much the same thing. So go ahead, see if you can do C. So here we just combine our like terms. We get minus 6 minus 3I. Try D. We're going to go ahead and get 7 minus 3I. Oh, I guess I should have shown how I got that. Sorry, I just like did that in my head, and that was rude. We have to distribute the negative. We get plus 4 minus I. Then we combine like terms, 7 minus 3I. All right, so now we're going to go ahead and write the product. Product means we're multiplying now. So again, you're going to treat i's like variables until we end up with powers on the I. Okay, so we go ahead and distribute this just like we normally would. So we would do negative 2.5 times 8, and we get negative 20i, because there was an I on that negative 2.5. Then we're going to go ahead and do negative 2.I times negative 9, excuse me, which is going to give us a plus 22.5. And then we have I times I, which gives us an I squared. So at this point, we can go ahead and we know that I squared is equal to negative 1. So we can replace the I squared with a negative 1. So we have 22.5 times negative 1, which is going to give us a minus 22.5. Now again, we want to keep it in that A plus BI, so we're going to put that imaginary part second. All right, next one. And really, you're just going to FOIL this out, something you guys are very well acquainted with. So we get 9 plus 6i minus 6i minus 4i squared. We combine our like terms. These guys can go away. And I have 9 minus 4i squared. And then we know that we can replace the I squared with a negative 1. So we end up with negative 4 times negative 1, which gives us a plus 4. So we have 9 plus 4, which gives us 13 as our answer. All right. Next one here. Let's go ahead and distribute the 2/5 I times 10. Now, if fractions scare you, that's A-okay. You can use your calculator, right? So you can do 2 divided by 5. Make sure that when you plug fractions into your calculator, you always use parentheses. Then we're going to multiply it by 10, and we get 4. And then we're going to have an I on it. And then we're going to do 2/5 times negative 5/2. So we end up with a minus 1, and then we have an I times I, which gives us an I squared. So again, we know that I squared is equal to negative 1. We get 4i plus 1. So when we write it in our proper form, we're going to have 1 plus 4i. All right, next one. We're going to go ahead, FOIL it out. 1/2 times 1/2. Hopefully you can do that in your head. If you can't, that's fine. You just go to your calculator. 1 divided by 2 times 1 divided by 2. And you get 0.25 or 1/4. So we end up with 1/4. 1/2 times negative 2 is going to give us a minus 1i. So a minus I. Then we multiply out the 2i. 2i times 1/2 is going to give us a plus 1i or plus I. And again, you can just do fraction operations on your calculator. 2 times 1/2, and I get 1. And then I've got 2i times negative 2i is going to give us a minus 4i squared. These guys cancel out in the middle, and we've got 1/4 minus 4i I squared, which we know we can write this as negative 4 times negative 1, which gives us 1/4 plus 4, which there's a couple different ways you could write this. You could just do it on your calculator. I'm perfectly fine with that. So you're going to do 4 plus 1/4, and you're going to get 4.25. That is an acceptable answer. You also could get that in fraction form, math enter, and we get 17/4. All right, so let's go ahead and try D. So it says solve x squared plus 4 equals 0 using the square root property. So if you recall, when we use the square root property, we need to isolate the x squared term. So in order to do that here, we're going to subtract 4 from both sides, and we get x squared equals negative 4. Now, before, when we square rooted a negative number, we would have said that there's no real solution. But now, we can give the imaginary solution. To undo a square, you take the square root, and whenever you add in a square root symbol, you have to add in a plus minus. So we have plus minus root negative 4. And we know that negative 4 we can break down into, I'm going to do this up here so we have space, negative 1 times 4. We can pull this out as an I, pull this out as a 2, and we get plus minus 2i. So our two solutions here would be 2i and negative 2i. All right, this one here. Again, we need to isolate the x squared, subtract 49 from both sides. Go ahead, tell me what the imaginary solutions to this equation would be. All right, and then this one here, same thing. Oh, I guess I should solve the, I'm struggling. We should solve the equation. So we added a square root. We end up with x equals plus minus the square root of negative 49, which we know we can break down into negative 1 times 49, which gives us 7i. So plus minus 7i. So we have 7i and negative 7i. All right. So here we have to go ahead, isolate our x squared. We're going to subtract 25 from both sides. And we get 9x squared equals negative 25. I don't know why I put a 4. Then we divide by 9. Now, you could go ahead and see if you can simplify this, but I'll tell you this fraction's not going to simplify. So then we can go ahead, take the square root of both sides, and we get that x is plus minus the square root of negative 25 all over the square root of 9. Which is going to give us plus minus 5i over 3. So our solutions here are going to be 5i over 3 and negative 5i over 3. All right. Now, example F, it says the quadratic equation x squared plus 9 has the solutions of 3i and negative 3i. How many times will the graph x squared plus 9 cross the x-axis? So this guy only has imaginary solutions. He doesn't have any real solutions. Real solutions are your x-intercepts. Imaginary solutions means that the quadratic is not going to go through the x-axis. So how many times will the graph cross through the x-axis? 0. Because we have no real solutions, which equals no x-intercepts. And we can go ahead and graph this on Desmos to see what this graph actually looks like. So you can make sure I'm not lying to you. So we've got x squared plus 9. And you can see that this quadratic has 0 real solutions. It doesn't go through the x-axis at all. We don't have any x-intercepts, which is why it has imaginary solutions.